Hi, my name is Dana Golden. Today we're going to be going through the code for logistic regression. So we're going to start off by defining some data. So this is our X data, this is our Y data. Recall that with logistic regression, we have a binary variable. So it's a Y variable with classes 1 and 0. So we're going to run logistic regression from scratch, starting with maximum likelihood. So we have our sigmoid function 1 over 1 plus np dot negative exponential of z. So we're taking the negative exponential of our z variable. This is our sigmoid function. And then we get the log likelihood of z. So we get z, which is np dot dot, the dot product between x and our weights. Weights are going to be defined by the function because this is going to be followed by maximum likelihood. And then we're going to get the log likelihood is the sum of y times z minus 1 minus np dot log 1 plus np plus dot exponent z. This is a log likelihood. This is also the what's called the hypothesis function, or the minimum entropy functions. This is logistic regression. We add our intercept. Intercept equals this 1s, x equals x such np dot h stack intercept x. We get our weights, and then we take steps. We change our learning rate based on gradient descent. Gradient is just x dot transpose times y minus predictions. That's going to be our gradient. And then we have weights are changing by the learning rate times the gradient. So we take a series of steps, and with each step, the log likelihood gets closer and closer to 0. In this case, we are waiting for the log likelihood to go through 10,000 steps. So it goes through 10,000 steps, and as you can notice, it converges. Normally, you'd want a negative log likelihood, so you have something positive that's decreasing, because that's a cost function. But here we have a net log likelihood that is not multiplied by -1 to get negative. We could, if we want to, multiply it by -1 to return the negative log likelihood function, which will give you a positive cost function. And there you go. Your log likelihood is decreasing. And when the log likelihood is decreasing, that means the cost function is decreasing, which is a good thing. So now we do the same thing with sklearn. We get our predictions. So CLF, we're fitting our model, and then CLF equal predict x. So let's see what happens with CLF predict x. We have our predictions. So as you can see, it predicts 1 and 1. You can also get the probability of those predictions there. It's probability of one class, the probability of the other. And then the score. In this case, both were predicted correctly, so the score is just 1. Now we're going to do the same thing with PyTorch. So this is kind of a precursor to neural networks, where we have a super, which is our model, and then one linear layer, and then we do outputs, which is the linear layer, and then a sigmoid activation function, and then we're just going to do our training. So as you'll notice, this is basically what we were doing just a moment ago, but this now is with PyTorch. So this is a basic linear logistic regression, which is a basic neural net. So here we are. Here we have the loss function decreasing. This time we did have a positive loss or a negative log likelihood function. And we do the same thing with the iris. And then we get predicted probabilities. We get predictions. And then we get the score, which is 0.9733. In this case, the score is just the accuracy which is how likely a something's weird here. Those log likelihoods are infinite. Let's debug what happened here. X, Y. Well, it seems to have created the right predictions anyways. But so yeah, that's logistic regression. That's how you code it up. Thank you, and I hope you have a great day.